All right, it's time to start the annual science experiment. Every year, my students do a big science project for the state of Oregon, and it's time for that again. So here's your Monday lesson plans. And as I explain in this paragraph right here, you've already done this 4 times, so you should know how to do it. Please look through the simulations to decide on an investigation. We're going to go with some simulations instead of physically doing an experiment because it's cleaner, and as long as you have an internet connection, everybody has the same equipment. So you may not choose what we've already done. So there are so many things to choose from. That's not going to be a big, deterrent. Remember, as long as you are only allowing one variable, which means one independent variable, because the dependent variable, it sort of responds to what you do with that independent variable. Anyways, the sky's the limit. Pick something that you actually understand what you're doing. Use this generic write-up. So this is the generic write-up you've seen so many times before. And let's see. I think I'm going to take away the highlighting. Just do that for you. No highlighting. All right, so you got to know what you're doing as far as a question before you can start changing the independent and dependent. So we're going to go to these sims, and this one leads you to projectile motion, but go ahead and click on, you can get out of this unless you want to do a Canon lab. Of course, I've already gobbled up 3 or 4 different, investigations. So click on PhET down here. Go to the PhET website and click Sims, all Sims. I would say physics, chemistry, but there's probably other ones you can do too. But physics and chemistry are probably, understandable, much more understandable, fewer variables. I don't know. So let's see. What would be a good, and I want you to pick something that you understand how to do. So if it's like, if you look at this diffusion and you're like, I don't know what that is, then don't do it. Skate park sounds like something you'd probably understand. Or forces, these people playing tug of war, that's probably understandable. Hooke's law, John Travoltage. Yeah, so really doesn't matter. Pendulum's a good one. Yeah, a lot can be done with pendulums. So are, a lot of those other ones were good, but I don't want to give away how to do too much because then you won't be able to do it. You'll feel like Mr. Poole already stole that one. But just as an example, let's go to the lab here. And let's see, maybe the rate at which it swings back and forth is influenced by the length of the string. So if we increase or decrease the length of the string, you might be, I wonder if it'll swing faster. Because, you've been on swings, and when it's a really tall swing, it seems like it, swings slower. So you could do an investigation on the relationship between the length of the string and the time it takes to get back and forth. So that would be easy. Or you could leave the length alone and instead change the mass. Find out, how does the mass of a pendulum affect the time it takes to get back and forth is called a period. So how does the mass affect the period? All right, now I'm already giving away some questions because you could use that. You could actually write that. How does the mass of a pendulum affect the period? Done. You've got your question. Then you just say mass, period. Mass, period. Everywhere there's IND, you write mass. Everywhere there's a DEP, you write period. It's so easy. There's actually no excuse for not being able to do this procedure. Just describe how you're doing it. Materials, explain the stuff you're using, if you were to physically do it. Constants, we already talked about that, the things that you're going to keep the same. And then once you do the experiment, if your hypothesis, your prediction that you wrote in here turns out to be true, you say, the data supported my hypothesis, and then you repeat it, but in plain language. You say, as I increase the blah, 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 the blah, blah, blah. Sources of error is where you pretending that you did it in real life, explain the things that got into your experiment. So with like the pendulum, you might say, as much as you tried to eliminate the tiny air currents in the room, there surely were air currents that, I don't know, you probably turn off the ventilation system in your house. Even though that would be a tiny influence on the way this swings, depending on how picky you're being, it would have some it would affect it to some degree. In real life, a pendulum would also have some friction right here, and you would want to mention that. Of course, if the friction is constant at all times, it affects all trials the same. But that's what you're looking for, is stuff that would influence one trial from another. So just use your imagination, explain. You could even say that you tried to hold the pendulum at exactly this angle, but it's impossible to make it exactly the same every single time. I mean, roughly it is possible, but if you got super picky, you know that every single trial you're releasing the pendulum at a slightly different angle, and those are worthy of saying source of error about. Okay, so that's how you do it. And if you're confused, like you're having amnesia as to how to do it, here's all these video guides where I explain 4 different labs that we've done in the past, how to do a good experiment. So, yeah, have fun.